In this video, we are looking at converting ordinary numbers that are all between 0 and 1 into standard form. Now, when you're new to this, it helps to remember 10 to the power of negative 1 is simply 0.1. 10 to the power of negative 2 is 0.01. 10 to the power of negative 3 is 0.001, and so on. If you've watched the previous videos, you'll know that for a number to be in standard form, it needs to look like a times 10 to the power of n, where n is an integer, that means a whole number, whether it's positive or negative, and a has to be at least 1, but it also has to be less than 10. Now let's have a look at the first question, 0.3. I'm going to position the decimal point after the 3 so that I end up with 3. That is to make sure that my a in my number in standard form is between 1 and 10. So I've got 3. And to get that to be 0.3, because at the moment they're obviously not equal, what I need to do is multiply this by 10 to the power of negative 1, because that's 0.1. 3 times 0.1 is 0.3. Therefore, I need to multiply by 10 to the power of negative 1. Pause the video and have a go at the next two questions for yourself. Here are the answers. 0.08 is 8 multiplied by 10 to the power of negative 2. 0.004 equals 4 times 10 to the power of negative 3. Now, let's look at a quick shortcut we can take with these. What we can do is look for the first non-zero digit in these numbers, these ordinary numbers, and count how many places from the units column they have been shifted to the right. So this 3 is one position to the right of the units column, and we end up with 3 times 10 to the negative 1. That was when it was one position to the right. Let's look at this one. The first non-zero digit is 8. And where is that 8? From the units position, it is 2 places to the right. And we end up with 8 times 10 to the power of negative 2. In this question, we've got a 4. That's the first non-zero digit. And where is that 4 in relation to the units position? Well, it has been moved 1, 2, 3 places to the right. So we've got 4 times 10 to the power of negative 3. 3 places to the right, 10 to the power of negative 3. We can use this idea to help us with the next one. I've got 0.58 here. Now that's not between 1 and 10. I need to position the decimal point actually in between the 5 and the 8. So I would have 5.8. So that is a suitable value for a. It's between 1 and 10. And that is going to be multiplied by 10 to a power. 10 to the power of what though? How do I find this index? Again, I can look for the first non-zero digit. So the first digit that's not a 0, that's the 5. And we can see it has moved 1 place to the right of the units column. So that means we need 10 to the power of negative 1. We can just check this makes sense. 5.8 times 10 to the power of negative 1. That means it's 5.8 times 0.1. And 5.8 times 0.1 is indeed 0.58. You can also check the previous two, by the way. 0.004 we're saying is 4 times 10 to the negative 3. So 10 to the negative 3, which is 0.001. And 4 lots of that is indeed 0.004. Pause the video and have a go at E and F. Here are the answers. For E, we need to position the decimal point just after the 8. So we've got 8.2. That's the only way we can get these digits to form a number between 1 and 10. And I need to multiply that by 10 to the power of negative In this case, the 8 has gone from the units column 1, 2, 3, 4 places to the right. So it's 10 to the power of negative 4. For f, we've got 4.09. That's the only way I can position the decimal point in here to get a number between 1 and 10. And I need to multiply that by 10 to the power of negative. Well, where has the 4 moved? It has moved from the units column 1, 2, 3, 4, 5 places to the right. So if I've got 4 in the units column, I need to move it 5 places to the right to get it to become this number. And for that to happen, I need to multiply it by 10 to the power of negative 5.